So you'll hear me refer to them as read in and read out. They're not going to get referred to that on the AP test, but you will notice as we start to look at FRQs, they're going to ask you for the information in these very similarly to how I word it on here. So again, we're going to revisit this. It's like a glimpse of it today. We'll have a glimpse of it next week, etc. So in this first problem, we have, after the AP Calc exam, which this is probably fairly true, many students post memes. They post memes at a rate of M of t equals blah, 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 blah. So right away, calculator problem. So if I'm doing this problem and it's the AP test, I don't even read any further. I'm going to, at this point, take out my calculator and put that function into Y1. I'm also, because I'm semi-hypochondriac, going to hit mode and make sure I'm in radian mode. Because if I'm not, I've missed the entire problem. So I check that I'm in radians, I clear everything off my Y1, Y2, and I type this in my Y1. So 231 sine alpha y equals, get that fraction, pi x over 24. And then I'm looking at that interval and it's saying 0 to 24. So I'm going to go, all right, I'm going to change my window maybe to like -2 to 26. Because I know my x values don't need to be calculated really much behind it or much ahead of it. But you always have to show it. And then I might sneak over to my table and type in 0 and 24 and maybe something in between to give myself an idea of what my y values need to be. And I see that it goes 0, 0, and then at 12, it was at 231. So my y values, I'm going to make my scale pretty big. So my y min, I'm going to go -10. My y max, I'm going to go for now at 300. I'm going to make my y scale 50. Now I'm just going to hit graph. I haven't even read the problem. I don't know what I need to do, but I now at least know, or my calculator is starting to graph that curve, because the graphing on the calculator takes the longest. So I'm hitting graph. I know it's working. I go back to reading my problem. And I'm like, all right, M is measured in students per hour. So I'm thinking in my head, students per hour. Immediately, I should recognize that M is like a derivative. It's in a rate. So M is like a derivative. But they tricked me because they called it M instead of M prime. But it's a rate. So it's students per hour. After 12 hours, the College Board begins canceling scores of students for posting memes. All that work for nothing. The College Board begins at hour 12, and its function is C of t equals blah, 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 blah. So again, another crazy function. Guess where my crazy function is going? Y2. C and N are both measured in students per hour. S of t is to represent the number of students who have posted memes but have not yet had their scores canceled, the lucky ones. After 24 hours, how many students have posted memes? So A doesn't care at all about C. A says after 24 hours, how many students are supposed to meet? So A is going to be the integral of n. So we say, all right, I want to find the integral from 0 to 24 of m of t dt. Don't write the function out on the AP test. Use its letter or on my test. So 0 to 4 of m of t dt equals. That's it. That's all you gotta write. Then you go to your calculator. So you can hit quit, hit math 9, 0, 24. Don't retype the equation in the parentheses. Hit bars, y bars, function, y1, and let it put what you put in y1 in your calculator. And we get 3,529.4. So it says round to the nearest whole number. So am I going to 29 or to 30? 29, because it was 0.4. 5 and below says down. What does this 3,529 represent? What are my units? Okay. We're done? We move on. At t equals 19, is s of t getting larger or smaller? So remember, s of t represents the students who have not had their scores canceled but posted a mean. So s of t is going to equal m of t inside its integral minus c of t. There's where AP is coming to get you. M of t goes from 0 to 19. C didn't start until what time? So the mistake that everybody tends to make is they do C of t from 0. But it says at t equals 19, is s of t getting larger or smaller? So how do I know if something is growing or not? So right now, this would represent the number of students. It wouldn't tell me growth. What function tells you growth? How do you know if something is increasing or decreasing on the original? If I want to know if the original function is increasing or decreasing, what do I investigate? Yeah, investigate the sign of the. So if I want to know if s of t is increasing or decreasing, I don't want to look at s of t, I want to look at its. So I need s prime of t. And what did we say we know about the derivative of an integral? Yeah. It becomes just the function. And it becomes like that function at its upper or lower points on y. So s prime of t becomes m of t minus c of t. Because we wanted its derivative. That's where it gets like tricky, right? Because you have to understand what it's representing. So now I want to know s prime of what number? 19. So what you're going to do, this is really cool again, go to your calculator, you're going to type the number 19, you're going to hit STOX and hit enter. What that's going to do is that's going to make X 19. So if you hit like X and hit enter, it'll say 19. So what you've done is you've placed a value in for X. Now you're going to hit that y bars function y1 minus y bars function y2. And you're going to subtract on your calculator y2 minus y1. And what it does is it plugged, y1 minus y2, yep. What it did is it plugged 19 in to both your y1 and your y2. So let's do it. I never ordered anything, I got busy. Nope, I'm this morning. Alright, bye. And then y bars function, y1, and then minus y bars function, y2. Yep. So now you have to do that minus that. Yeah. But you could have typed like, So we get negative, and really I don't care about the number, 425. What I care about is the negative. So if the derivative is negative, then the amount of students are decreasing. So that means it is getting, since s prime of t is less than 0, s of t is getting smaller at time t equals 19. And then the famous last question, at what time is the number of students, at what time is the number of students that have posted means but have not yet had their scores canceled a max? So again, similar to what we were looking for in that other problem. We want a max, so we need the candidates test. What do we need the candidates test for? We need the candidates test for S of t. So at what time is the number of students have posted means but have not yet had their scores canceled a max? How many students have posted means but have not yet had their scores canceled at this time? So we are going to start with S of 0. So S of 0 would equal, and again, I erased mine, but remember S of t is equal to the integral from 0 to t of m of t minus 0 or 12 to blah, blah, blah. So if we want to know S at 0, then we're going to plug 0 in for my time up there. What do you know about an integral from 0 to 0? When would my next point of, concern occur? Well, my points of concern occur when the derivative is equal to 0. So what did we say the derivative of s represented? Well, s prime of t was m of t minus c of t. If I want my derivative to equal 0, what does that tell me about m and c? M and c, sorry. When is the derivative of s going to be 0? When m and t same. How could I find that? By going to my graph and finding points of intersection. I'm looking for those points. So on my graph, I see 2 points. I see one near the very, very, very beginning. So I'm going to investigate S of 0.992. And then I'm going to investigate the other point of intercept. At 18.7775. And then I have to do a final investigation at 24, so that's when both my integrals end. So again, this point here, 0 to 0.09. Of m of t dt. I don't care about the integral for that function of c because c doesn't exist yet. I'm going to go up on my calculator, and I already put m of t in an integral, so I'm going to go highlight it, hit enter, it brings it back down, and I'm going to change that 24 to that 0.0992. I like to just truncate at 4. I don't look for rounding, I just truncate. Then I'm going to take that same integral, I'm going to highlight it again, hit enter. That's going to bring it down, and I'm going to change that 0.0992 to 18.7775. And then after that, I'm going to hit minus, go to math 9, bring another integral onto the same line for the c. But again, this integral for m is 0 to 18.7775. The c that I'm going to subtract can't start till 12. So on my calculator, C of t is bars 2. So it's 12 to 18.7775. Bars, y bars, function y2. And I get a really big number. And then I'm going to go up, I'm going to highlight that full line again and change all those 18s to 24s. And again, there's a little delete key at the top, so you can delete numbers. Like I get rid of that 18 by just hitting delete on top of it. It won't delete my integral, it just deletes the numbers. So the maximum number of students who have posted memes but have not yet had their scores canceled is approximately 2,774. So this one's different than the other one because now it's not at an endpoint. It is at a point in the candidates test. And it's a point you wouldn't have easily seen because you had to get the points of intersection. So you had to, again, understand what they're looking for and why. So it says how many students have posted these but have not yet had their scores canceled. That's 2,774. Justify your answer. So again, my justification would be that this is a critical point and therefore it matters. This one is easier. So it says the rate at which people enter the zoo and exit the zoo is modeled by that function there. So enter E, leave L. Both E and L are measured in people per hour. So again, E and L both represent rates. So these functions are valid from 8 a.m. to when they close. So 8 a.m. represents time 0. They close at 8 p.m. then that means, because they're open for 12 hours. How many people entered the zoo by noon? So what you're going to do is go to your Y1, erase it from the last problem, Y2, erase it. Put the 23 natural log x squared plus 3x plus 1 in. Put the 63 plus 50. Inverse tan means you have to hit second tan. That's what that -1's implying. Put your alpha y equals and get your x minus 6 over 2. Make sure you have all the parentheses and all the stuff matching it exactly. So how many people have entered by noon? We are investigating then 0 to 4 of E of TDT. They already hinted at it represents people, so I might just write down people for my units and go back to my integrals. Again, you can hit second enter and it will pop back up things you've typed too. So what's nice is you already have the 0 to blank of y1 dx. So I just copy and paste that down again and delete the upper bound and change it to the upper bound I want. This answer did not tell me to round, even though we're talking about people. AP calculator says 3 decimal stuff. So do not round if it does not ask you to round. Part B, 20% of those people who leave the zoo are selected at random to receive a special discount ticket for their return. How many people have received a discount ticket by 5 p.m.? So 0 to 9, L of TDT this time. So at 5 p.m., 395.9018 people have left. So I want 20% of that. So to get 20% of that, I'm going to take 0.2 times that 395.9018. And I get that 79.1803 people have received a ticket. N of T represents the number of people who have entered and now left. Find the value of N of T and explain the meaning of N of T in the context. Find N prime of 10 and explain the meaning of N prime of 10 in our context. So N of 10 is super easy. We're just going to take our integral from 0 to 10 of E of T dt minus L of T dt. I can do that all in one integral. So it's going to be y1 minus y2. And I get 273.6351. So what does N of 10 represent? It represents the total number of visitors at the zoo at that current moment, right? Because it's the people who have entered minus the people who have left. So N of 10 represents the number of visitors at the zoo at 10 hours after opening, or 6 p.m. So it represents the number of visitors at the zoo at 6 p.m. or at 10 hours after opening. So what would the derivative represent then? N prime of 10, well, no, it's super cool, it's 2. So what you can do now is hit math 8, put x down below, and you can actually highlight the integral from above, and it will put it in the derivative down below, and your x value in this case is 10. So you'd want the derivative, so you want to like look at that. Oh, you did it. Perfect. Yep. Good. And we should get negative 6.228. Uh-oh. All right. So maybe don't do it that way. That was silly of me. I could have just made it easier. All you have to do again is 10 sto x. And I can 0 to so store the 10 as x and then do bars, y bars function, y1 minus bars. Now I get my negatives. I wonder what the derivative will be in that one. Your integral inside had to be x. What would the units on that be? So the derivative of n becomes the originals minus each other, right? So the originals are defined as people per hour. So this means that people leaving the zoo at 6 p.m. at 10 people per hour. people are leaving the zoo at 6 p.m. at 6 people per hour. So again, it means that the people are leaving the zoo at 6.228 people per hour at 6 p.m.
Yeah, that should make sense. You're leaving the zoo at 6 o'clock. It's dinner time.
It did for me too. That was me not thinking about the fact that the upper bound is at 10. When it did it to 10, it got a number, and then I took the derivative of the number, which is 0. The upper bound had to be generic. Alright. At what time does the model predict the max people in the zoo? So again, when would you have a max? This is that candidates test. So I'm going to give you like time to breathe. Again, all you do is set n of t equal to 0 on its derivative, which means it's e of t equals L of t. You find your point of intersections, and then do all your integrals for the points of intersections and the endpoints. Just do 1 to 7, don't do 8. So I just think it's too much. The first couple are the easy, they're just our graphs again. So do not do the last page. We'll do that to start tomorrow. This is the harder of the two parts.